Soilcast. Boden, Umwelt, Klima.
In the last episode, we talked about physical weathering, and now we want to focus on chemical weathering to complete the weathering topic. You maybe think that chemical weathering sounds harmful, but this is usually not the case. On the contrary, without chemical weathering, life on our planet would be impossible, so we actually depend on it. For example, chemical weathering is responsible for getting plant nutrients out of minerals in soils. I will explain to you how this works exactly in the next few minutes. I have already explained to you in the previous episode that physical weathering only changes the grain size and shape of a rock or a mineral, but not the chemical composition. However, during chemical weathering, chemical reactions take place, so at least one substance reacts with another. Our first substance would be a rock or mineral, but where does the second substance come from? It's freshly delivered with the water infiltrating in the soil or the rock. In soils, liquids such as water exist alongside solids like rocks, and soils are therefore a multi-phase system. We refer to the liquid phase of the soil as the soil solution, as it consists not only of pure water, but also contains a variety of dissolved substances. The interaction between the soil solution and soil particles is key to chemical weathering, as we will learn in a moment. In places with only little precipitation and little water running through the soil, there isn't enough soil solution for chemical weathering to work efficiently. So climate is really one of the key drivers of weathering and determines which form of weathering predominates. In climatic zones with high precipitation, such as rainforests, chemical weathering is much stronger than physical weathering because there is more than enough water for the soil solution present. In dry climates, such as deserts, the effect of physical weathering outweighs chemical weathering since there isn't enough water for efficient chemical weathering to occur. But how exactly does chemical weathering work? As with physical weathering, there are a large number of processes that contribute to chemical weathering. I would like to introduce you to 3 of them in more detail. The first process is called hydration and is quite easy to understand in the kitchen by dissolving table salt in water. This substance you know as table salt has a different name when we talk about it as a mineral. Then it's called halite. Like halite, all salts can be dissolved in the soil solution through the process of hydration. The water molecules in the soil solution enclose the ions of the salt and release them from the ion lattice. This hydration shell makes them mobile in the soil solution and allows them to be transported. In principle, all salts are susceptible to hydration, but they differ in their solubility, which is basically their desire to leave the lattice structure. Strictly speaking, hydration is not a chemical reaction, as there is no actual conversion of substances. This is different in the second process called hydrolysis. Here, the water in the soil solution reacts with a mineral to form a new substance. This is particularly noticeable in soils when the soil solution is acidic, a process known as protolysis. Soil acidification can have a variety of causes, which we will discuss in a separate episode. We humans are responsible for strong acid rain that additionally acidify soils. However, it is important to mention that soil acidification is actually a natural process that occurs over long periods of time. The more acidic the soil solution is, the stronger protolysis gets. The last process I would like to mention is oxidation. Everyone has witnessed oxidation because it's the process that is responsible for rust forming on the exposed iron of a car. I just want to quickly highlight how this process works without causing too many chemistry class flashbacks, hopefully. In redox reactions, a reaction partner is oxidized. That means it releases one or more electrons, and these are transferred to another reaction partner, which is reduced accordingly. Let's now apply this to our rust example. In this case, iron is oxidized and electrons are transferred to oxygen and water, which are reduced accordingly. These redox processes also take place in soils. Iron minerals react with the soil solution and are weathered by oxidation processes. And just as on our rusting car, reddish-brown iron oxides form that give the soil its characteristic color. What is exciting for us is the significance of chemical weathering for life on the planet. Chemical weathering transfers atoms from minerals into the soil solution. This process is essential for plant nutrition because plants need nutrients. In most cases, these nutrients come from minerals. Without weathering processes, plants would never be able to absorb these nutrients as they would never enter the soil solution. So chemical weathering influences the availability of plant nutrients but also contributes to the mineral diversity of soils. Clay minerals would not form without chemical weathering, and they play a prominent role as exchange minerals in soils. These clay minerals can exchange cations on their negatively charged surfaces. The cations that are exchanged at this surface are often important plant nutrients such as potassium ions, calcium ions, and ammonium. Therefore, clay minerals strongly contribute to nutrient storage. They are the product of weathering silicate minerals, which releases silicic acid. This silicic acid arranges itself into interesting spatial structures, creating the building blocks for clay minerals that are able to exchange these important cations plants depend on. If you want to know more about clay minerals, there will be an entire episode about clay minerals in the future. So let's summarize. Weathering processes are diverse and they are the basis for life on Earth, as they can release many plant nutrients from solid minerals and make them available for plants. They are also important drivers for soil development and make a fundamental contribution to mineral diversity. I will now get to work and contribute to the diversity of further textbook episodes of the Soilcast. Have a great time until the next episode.
Der Soilcast ist für euch kostenlos und das soll auch so bleiben. Ihr könnt uns dabei helfen. Derzeit unterstützen uns etwa 1% unserer Zuhörerinnen und Zuhörer, zum Beispiel durch eine kleine Überweisung auf das Geschäftskonto oder via PayPal. Wie das genau funktioniert, seht ihr auf soilcast.de unter dem Punkt Unterstützen. Das Geld wird für die digitale Infrastruktur verwendet und darüber hinaus in Technik investiert. Vielen Dank für eure Unterstützung.